John Black, Super Chemist. Believe it or not, this is part 5 of this GRIGNARD reaction. It's actually going to be a part 6 too. But this part 5, I'm just going over the stoichiometry, mistakes I made, and blah blah blah. Part 6 though, I'm going to do this reaction again. It's just going to be one single video where I show the differences that I did, some, like the mistakes of, and fix all those mistakes, and let you know if the yield went up. Alright, now I am unsure about the mechanism when it comes to using carbon dioxide as your electrophile, because it has 2 carbonyl groups. So I'm unsure. Normally it would go through to this and you'd have a tetrahedral intermediate, but obviously it's not tetrahedral if you got a double bond here. So I don't know what you'd call that, or even if this is what it forms, but I'm just trying to do an analog to what I know how it works with aldehydes or ketones. I've never seen the mechanisms for CO2, so I'm unsure here. But let's just say that this is what happens. I bubble into CO2. Remember at the beginning of the video, we already made the ethyl magnesium bromide in a previous video. We tried to make 1/3 of a mole our theoretical yield, but that doesn't mean that our yield was 1/3 of a mole, right? Obviously it wasn't, because we didn't get good yield. CO2, I chose, since this was 1/3 of a mole, okay, I chose a full mole for the CO2. I figured 2/3 of it would be lost because it's not very soluble, you know what I mean, in the ether, and I'm bubbling it through, you know what I mean. I didn't think it would, it's just an arbitrary guess, really, you know what I mean. I'm not basing it on anything, but I figured I can't lose more than 2/3, you know what I'm saying. It sounds like a good number to me, so that's what I picked. Like I said, I'm not basing it on anything though, except just guessing. Now this is where I think I made a big giant mistake. I think, but I'm unsure because I don't mention in the video how many grams of baking soda I used to make the carbon dioxide. But when I was doing this just now, I looked up, because I like to look it up just to double make sure, you know what I'm saying. I thought before I looked it up that it was 1 mole of this for 1 mole of that. So I'm thinking that I only put 84 grams into the flask making the carbon dioxide. If I did, that's only 1 mole. So it would only make 1/2 of a mole of carbon dioxide, and I was planning on a full mole, right? Now if I made it 1/2 a mole, and our theoretical yield is 0.33, that's barely above what I needed to be, you know, if it was quantitatively reactive, then yeah, that would be great, 0.5. But I'm thinking 2/3 of it is going to get lost just in the atmosphere. Alright, now I want you to think about it. If I have 1/2 a mole, 2/3 of it is going to be lost to the atmosphere. That only leaves me with 1/3 of it, right? So I divide by 3, that gives me 0.167 moles of CO2. The theoretical yield is 0.333. So if I messed up and I only used enough baking soda to make 1/2 a mole of CO2, I'm see, this is doubled. 2 times this basically equals 0.333. So 1/2 of my yield is lost right there by this one single mistake. If it was a mistake, I still don't know. I can't remember what I put into that flask, and because I really, in my mind, I was thinking 1-to-1 ratio, and as you can see from the equation, it's a 2-to-1 ratio. So I guess when I do it again, we'll see and know then. But anyways, I should have put in 168 grams of the sodium bicarbonate. That way I would produce, that would be 2 moles of that, and it would produce 1 mole of the carbon dioxide, which is what I wanted. Now, once you produce this, you know, you keep bubbling the CO2 in, bubbling the CO2 in, bubbling the CO2 in, right? and then you got this, right? So there it is down here. That's an elk oxide. It's a salt. All right, now I want to go over a couple mistakes I was saying, because I really don't know the mechanism for this, because it is a double carbonyl type thing, CO2. Now you can see here I have it written. I keep calling this an elk oxide, and I'm editing, and I'm like, what the heck? That's not an elk oxide. That's a salt of a carboxylic acid, just like sodium propanoate, right? The reason why I keep making this mistake is because I don't know that mechanism. I do know the mechanism for aldehydes, ketones, esters, that kind of thing. I don't know about that. So I'm going to give you an example of a ketone doing this reaction so you can see what I'm talking about. And I also keep calling this a tetrahedral intermediate. It's not tetrahedral because this carbon does not have 4 things attached to it. It has 3, so it's not tetrahedral, obviously. But anyways, here's how the reaction goes. The magnesium is metal-cation, right? So this is the positive, right? The metal part. This carbon here becomes negative, right? Because this is positive, this has more of the electron density, so it becomes a negative carbon, right? This, you have an oxygen, always on a carbonyl. The carbon is positive and the oxygen is negative because it's more electronegative, right? So it pulls on the electron density, right, and makes this carbon positive. What happens when you have a negative and a positive? The negative goes up and attacks. Boom. This double bond goes up onto the oxygen and as an extra long pair of electrons, right? And this is what you end up with. See how the carbon is attached to 4 different things? That makes it a tetrahedral, right? Tetrahedral intermediate. And why is it an elk oxide salt? Because it's an alcohol where the proton was the hydrogen was taken off and it was replaced by some type of metal cation, right? Like if you had sodium, it'd be sodium elk oxide. This, you have magnesium bromide. So it becomes a salt of an alcohol, an elk oxide, right? Here, because one of these, this carbon right here, instead of it being an alkyl group, is a carbonyl group. You know what I'm saying? So it changes it from being an elk oxide to a salt of a carboxylic acid. Now, is this true? I don't know. This part down here, yes, it's definitely true. I know all about the Grignard reagents on all the, well, not all of them, but the aldehydes and the ketones and stuff, that easy stuff, yeah. This I never seen. I never read, I'm just guessing. Because if this would come up and go onto there, you would have your, this was your propyl magnesium bromide. It came up just like this did, connected onto the carbonyl, right? The double bond that used to exist here for the CO2 jumped up onto the oxygen, just like over here. But because of this double bond, you don't get the tetrahedral intermediate, and you don't get the elk oxide. You get the salt of a carboxylic acid. Now, I'm just guessing about this. It just makes sense. You know what I'm saying? Is it true? I don't know. This is true. This is a guess. Again, I'm unsure that this is actually correct. But it doesn't matter, because we're talking about trying to be equal, you know what I mean? So I put in, actually on this one, I put in a full mole of, I think I went over this pretty good in the video when I did it, so I'm not going to go over it that much. But I put a full mole in, 1/3 to quench it, meaning do this, change this salt into the acid, right? Just like if this was sodium propanoate. Now, it's not, it's magnesium bromium. It's the same thing, it's a salt of this propanoate. So in a third was to help get rid of some of the magnesium that was in there, and a third was for just to wash it. I was going to wash it with it. Then I used sodium hydroxide to take the acid and turn it back into a salt, but not this freak salt, a normal salt that we know, like sodium propanoate. I used 12 grams. Why? Because 40 grams is 1 mole. Remember, we divided everything by a third. That gives you 13.33. I figured at this point it's gone through 2 reactions. There's no way I did better than 90%. So I only took 90% of that, which would be 12 grams, and that's why I used 12 grams. Plus I figured some of this was probably water, so I even used less than 90%. But that's why I didn't use a whole third of a mole, because I figured at this time, even if I got an 80% on this and an 80% on this reaction, you know, the Grignard reagent and the actual Grignard reaction, even if I got 80% on both of those, overall, I would still only have a 64%. You know what I'm saying? In my yield. Alright, so what was my actual yield? Well, here's from Wikipedia, the molar mass, the density. That gives me the molar volume, which is 75 milliliters per every mole. We only used a third of a mole. Remember, we divided everything by 3. So we get 25 milliliters, right? I got 1.7 milliliters. So I divide it by the theoretical yield, and I get 0.068, which is 6.8%. Now that's an overall yield between 2 reactions, okay? So remember, because the first reaction was making the Grignard reagent, which was the ethyl magnesium bromide. And then we did the Grignard reaction, reacting that Grignard reagent with carbon dioxide. So to get that, you would take the square root of this, right? And you'd get 0.261, which is 26.1%. So that means that each reaction, on average, I mean, it's not exactly 21, it might have been 30% for one and, you know, slightly lower for the other, you know, vice versa. But on average, it was 26.1% yield for each reaction. Overall, though, since I got, say, 26.1% on the one, then the next one I got 26.1. Overall, I got a 6.8% yield. Both terrible, okay? But considering this is my first time, I didn't control adding the ethyl bromide to the magnesium, and that when I was making the ethyl magnesium bromide, also in that same reaction, I didn't put any ether in the pot with the magnesium when I was dripping in the ethyl magnesium, when I was dripping in the ethyl bromide. That was a big mistake. Also, as I just mentioned a couple minutes ago, I don't think I put as much baking soda in there. I only put half as much as I planned, I think. I'm hoping, because that would be good, because that I could easily fix that, you know what I mean? Just put the correct amount and double it, you know what I mean? Next time I do this reaction. Now, I am going to do this reaction. I got a lot of diethyl ether. That's about 500 milliliters of diethyl ether right there. And I'm making some more tonight, because I think I have a better way to make it, where you'll get, you know, I think my yield usually is like, it's low. I can't really remember. Or maybe it's like 70%. But I think there's a way to get 90%. I'm going to try, see tonight. But anyways, that's the end of the video. If you have any questions or anything, you know, ask me. I will do another video as soon as I get done with this, doing this reaction a second time. And I'll tell you, you know, it's not going to be long, you know, 4-parter. It's going to be a quick video showing you the differences of what I did. You know what I mean? Like putting the extra ether in the pot, and that kind of stuff. And then I'll tell you if it made any difference at the end of the video, you know what I mean? Because 26%, that's terrible. But it was my first time, so we'll see how good it goes on a second attempt. Anyways, you all have a great day, and always remember, science is great.